their end behavior is approaching what we call the end behavior asymptote. Horizontal asymptotes are actually called end behavior asymptotes because you'll have some rational function. You'll have a vertical asymptote, and x equals 2, and a horizontal asymptote of y equals 1. So its shape most often will be something like this. That's very typical of a rational function. Notice that as x approaches infinity, the curve is not shooting up into space. What is the curve doing? As it's getting closer to 1. And when I have a picture in front of me, I can be even more specific than that. This is approaching 1 from the bottom. When all I have is an equation, I'm not going to make you do that because actually that's a little bit extra and it's really hard to do with an equation. So if we have a picture though, it's easy. What happens as we approach negative infinity? We're also approaching 1, but we're approaching it from the top, right? End behavior is that asymptote. That's what's happening in water, approaching its asymptote. So yesterday we talked about how do we find these horizontal asymptotes. And what was the big, kind of like the 3 ideas we had? If the rational, power on top, power on bottom, if they match, then you're going to have a horizontal asymptote, and it's going to be at that ratio. So if it's 2x squared over 8x squared, it will be 1/4. If the bottom one is bigger, we still have a horizontal asymptote, but it's at 0. And if the top is bigger, we still have an asymptote, but it's not horizontal, it's a slant. Right? Okay, so here we go. Write limit statements to describe the end behavior of the following rational functions. This is example 2. You do not have a picture for A, B, and C, so you don't have to be specific. You know that in both directions, I'll do it in the order they do. This is the left. Left is approaching negative infinity. Some of you mess this up on your homework. Left, to the left, would be negative infinity, and then to the right, positive infinity. But it doesn't make any difference. The end behavior is the horizontal asymptote. Do I have a horizontal asymptote in problem A? Yes. And where is it? 1/3. So both of these would be 1/3. Now, if I drew this on my calculator, I could tell whether it's coming up from the top or the bottom. If I evaluated some, plotted some points, I'm not going to do all that. This is good enough. The end behavior is the horizontal asymptote. Now, what about B? That's going to be 0, right? On both ends, 0. Why is it 0? Because the power on the bottom is bigger. And anytime that happens, your fraction is getting smaller. It's heading towards 0. Now, what about H? It's going to have a slant asymptote. Now, we haven't talked about this yet, but we might as well go ahead. Now is as good a time as any to talk about it. We have negative 3x to the 4th minus x squared plus x over x cubed plus 4x plus 4. Now, what if this had been a 4? If that had been a 4, you would tell me that I had a horizontal asymptote at negative 3, right? You would look at these two right here and say, okay, that's going to cancel. I'm going to have negative 3. If that's a 3, you're still going to look at both of those, But because they're the biggest, we always look at the biggest because we're talking about what happens when x gets big. What happens when you cancel now? You don't get -3, what do you get? You get -3x. Your slant asymptote, I'm going to abbreviate SA, your slant asymptote is y equals -3x. Now, there might be more on there, but for this problem, we'll talk about how to find more in a while. But for this problem, I only want end behavior. So I want you to think about what is the line with a slope of -3, no matter what else is on the end of it. It might have a +2, it might have a -10, no matter what's on the end of it, what does y equals -3x look like? This. So as it goes off the page, the curve is going to approach that asymptote. So as we go to the left, as we go to negative infinity, as we go to negative infinity, what is happening to my y values? They're going up. And as I go to the right, what is happening to my y values? They're going down. So you can do the end behavior for slant asymptotes by simply looking at what that asymptote looks like. So if it had had a positive slope and it went up like this, then as we went to the left, our curve would be going down, and as we went to the right, it would be going up. Okay? All right. D, we actually have a picture, so now we can be more specific. For D, the left side limit would be what? They're both +2, and on the left, we are coming in from the top, and on the bottom, we're going in from the right, to the right, we're coming up from the bottom. Now, don't get confused by that mess of a picture. If you are doing end behavior, and where are you looking? Out here. You're not looking at that little parabola thing in the middle. That doesn't matter. We're looking out here. So what's happening as we go to the left? Getting closer to -1 from the top. And what happens as we go to the right? Same thing. We're approaching -1 from the top. Remember, end behavior is out there. Okay? All right. Which of the following rational functions has a slant asymptote parallel to the line y equals to 1/2x? All right. So first of all, what do you think about number 1? It does not have a slant asymptote because why? The powers match, same degree. How about 2? It does not have a slant asymptote. Its asymptote is y equals 0. Now what about number 3? Does it have a slant asymptote? Yes. And what happens when you put x squared over 2x? You get 1/2. So 3, for sure, 3 is going to have a slant asymptote parallel to y equals 1/2x. Did you agree with that? How about 4? No. If you were going to draw 4, and it's beyond the scope of this class, it's not discussed in our curriculum, but if you were going to draw 4, its end behavior asymptote would be a parabola. Why? Because you have x to the fourth and x squared, and the difference in the powers is 2. You can only have a slant asymptote, or linear, and have a slant asymptote if the difference in the powers is 1. Yep, yep, yep. So what would happen is, and I don't know, but what could happen is, let's say we got a vertical here, and then we have this kind of parabola being our slant asymptote, then the curve might do something like this. It would approach that parabola. Are you listening to me, Des? I am trying to answer your question. So the green thing might be a picture of something that had a parabolic asymptote. And, okay, can we talk about its end behavior? Absolutely, because its end behavior is going to model the asymptote, and if the asymptote is a parabola opening up, then what's its end behavior going to be? Up, up. Yeah. All right, next page. We're actually going to do this now. How much anesthesia should a patient get? We're going to not do 1. Because if he gets too little anesthesia, what happens? He hurts, right? When they cut him open or whatever. And if he gets too much, what happens? Could be really bad. He could die, right? All right. Number 2. The concentration of anesthesia in a person's bloodstream can be modeled by this equation. So someone has figured out, looking at the data, that the concentration is 35T over T squared plus 6, where T is measured in hours. The graph of C is shown. Okay. B, what is the concentration of anesthesia after half hour? What do you think? After half an hour. Well, if you look at the graph, you could say it looks like it's about 3%. But if we wanted to actually know what it was, could we plug 1/2 into our equation and figure that out? So the graph showed about 3. Let's see how close that is. About 2.8 is what the equation with the function would give us. All right. Can't look at the graph to do 24 hours, so you're going to have to plug it in. So go ahead, plug in 24 and tell me what percent, or what's the percentage concentration I have after 24 hours. And then go ahead and do 48 also. What'd you get for 24? 1.443? Anybody got 48 yet? Yeah, 0.727. Is that all right with everybody? Anesthesia is considered effective at a concentration at or below 5%. How long should the surgeon wait to start surgery? Well, look at your graph. It looks like he should wait about how long? And then he has how long to operate? 5 hours? Because it looks like it stops being effective at around 6. Would you agree with that? Everybody looking at the graph and figuring that out? After many, many hours, what do you anticipate will happen to the concentration of anesthesia? It gets smaller and smaller and smaller. For large values of T, which grows faster, the numerator or the denominator of our function? The denominator. When you start squaring big numbers, things explode, right? The denominator gets bigger. How is your answer to 5 related to the long run effect of anesthesia in your body? That's exactly what you told me. What happens if I wait a long, long time? It goes down and eventually it gets down to 0, right? That's the end behavior asymptote of that. It does in reality, it doesn't mathematically. Not mathematically, but we know that. Has anyone ever had surgery? Yeah. All right, were you under anesthesia? Yeah. Okay, you're okay now though, right? Because how many years ago did you have it? Months?
3 months ago.
3 months ago. So that anesthesia is gone from his body, right? We know that practically speaking, mathematically, no, but realistically, yes. All right, turn it over. You and your partner are going to do check your understanding, and then we're going to talk about it. So there's 4 questions here. Do those 4 questions, and then we will talk about them.
First of all, look at the front. I said slide. Yeah. So much Spanish there. We still have an exit. That's what I was x squared over 1 4. So it simplifies just x by x.
itself, but we have an x squared. Simplify.
Probably not. I won't know. So good.
Okay, we don't need to sing.
That's about it. Yeah. No, but this explanation still makes sense. It's not how you're just Oh,
It's my favorite part. I haven't heard it.
wait, sorry.
Oh yeah, probably.
Okay,
We'll drink this one for the drink.
does A have a horizontal asymptote, 1A? Yes, it does, at Y equals 0. Anytime the denominator is bigger than the numerator, your horizontal asymptote's gonna be Y equals 0. Okay, anytime, doesn't matter what you want. What about B? Does B have a horizontal asymptote?
Zero.
No.
Because the power on top is x to the fourth, and the power on the bottom is
X
x
squared.
squared. Now, is there an end behavior asymptote? Yeah, but it isn't horizontal, right? It's actually not even slant, is it? Because, yeah, x to the fourth over x squared, the power, yeah, can only be one. All right, were you able to write the equation of a rational function where the limit's 4/5? Give me an example. What did you come up with? 4x squared over 5x squared? Now, we gotta be careful with that one because that really isn't 4x squared over 5x squared. That is really just 4/5. That is just the horizontal line. So if you want to make the asymptote, the limit be 4/5, let's add something in here, right? That will change it. And you can do it on the top or the bottom. But that's what you gotta end up with. Now, do these have to be squares? No. Could you have 4x minus 8 over 5x plus 2? Would that work? Yeah. You already okay with that?
Why does that have to be like a 1 degree difference?
It says, I want the limit or the end behavior to be 4/5. That's horizontal. Not slant. Right? Yeah. Slant asymptotes have what kind of end behavior? Infinities, right? Yeah. This one has to be horizontal, so the powers have to match. All right, now we got our inset problem. Did you find the y-intercept of this? What'd you get, Alex?
25.
You got 25. Yes, because if we put in zeros, we get 50 over 2, 25. What does that stand for? What does that mean? 25 what? 25 insects at the start of the transfer, right? At the beginning? What's the limit? What did you say it was? Yeah, 2,500. And how did we get that?
That's just
The horizontal asymptote, 25 over 0.01. What does that mean? 2,500, interpret that.
It's the amount that the protected area can hold.
Exactly, that's your maximum population, right? What happens after that? Either there's not enough food around for them, or there's not enough space for them, but they can't go, you can't have more than that. And then the graph of this has the same end behavior as what? Negative 2x to the 4th, I heard from someone. Is that correct? Yeah. Where did that come from? 4x to the 7th over negative 2x cubed. What is the end behavior of negative 2x to the 4th? Down, down. So whatever weird thing this thing is, that's how it's gonna end. Down, down. Perfect. All right, let's go on to the next one. 2 important traits of a rational function. You already know both of these. We have zeros or x-intercepts when the function equals 0. And then we have vertical asymptotes when the denominator is 0. So the zeros come from the numerator, that's when the function is 0, but the vertical asymptotes come from the denominator, undefined. So we're going to take that little bit of knowledge and we're going to use it to solve this inequality. So here's my number line, because I'm going to do a sign chart like I do with inequalities. Here's my number line. And there are going to be 3 dots on that number line. Anybody want to take a guess where the 3 dots are? Negative 6, 2, and 3. Does that make sense to everybody? Now I know you see that symbol, and you want to color in those dots, but be careful. The only one you can color in is the 2. Why can't I color in the other ones? Because they're in the denominator. And if you color them in, then you're going to have a 0 down there, right? And that is not allowed. So even though the symbol is an or equal to, you can never color in the dots from the denominator because the denominator cannot ever equal 0. Are we on the same page? Okay, so now we'll just do our thing. Negative 7 would give me negative over negative negative. That doesn't work. 0 would give me negative over positive negative. That'll work. 2.5 gives me positive over positive negative. That won't work. And 4 will give me positive over positive positive. So that won't work. So are you okay with that answer? Easy enough? All right, you try the next one. Now the next one, you're gonna have to do some factoring before you start. about this before. Intuitively, you know that normally you alternate, like what happened here, like it doesn't work, it is shaded, it's not shaded, it is shaded. That's what the normal situation is. That didn't happen here because why? Because this one was squared, and anytime you have a repeated factor, it throws off your alternating. Okay, let's turn the page. We've got, see, we got 4. We only get 2 of them up here at a time. So do I have a volunteer, a team of volunteers, who will come up and do this one? And then somebody else will come up and do this one. Second one, right, and somebody do the first one? That's Alex. So Alex is done. Let me know if he can sit down or if he has to do some corrective action up here. Alex only has 1 dot on his number line, because there's only 1 X in the problem, right? X's get dots, numbers don't get dots, just X's. So, yep, 1 dot, that's it. Eklund's got 2 dots. Notice his -5 is open, because denominator dots are always open. Be 0. How does this look to everybody?
Pretty solid.
Okay,
Wait. I just have a question of why the -5 is open but the -2 is closed.
okay, somebody tell him, we just talked about that.
It's on the bottom. Someone who needed.
If it's on the denominator, they can't be a closed dot, because you can't have x is 0. Or on the denominator.
Or if you put -5 right here, what happens? If you let x equal -5, you get a 0 in the denominator. Is that allowed?
No.
X cannot
Oh.
equal -5.
Okay.
X cannot equal -5.
You'll get there.
Someday. Someday.
Are everybody else okay? Well, I made a mistake. I thought there were 2 more, but there's actually only 1 more. Let's look at example 6. I'm gonna have somebody come up and do 5, but 6 we're not even gonna do. Tell me why 6 is kind of obvious. It's always positive. Look at number 6. The numerator is always positive, it's 1. The denominator is always positive because it is squared. And what's gonna happen when you put positive over positive?
Stays positive.
It's gonna be positive. Is it ever gonna be less than or equal to 0?
Nope.
No, never.
So maybe like all reals except 1.
Well, could it a positive or a positive equal 0?
No, the answer is a no answer. Is that fraction ever gonna be negative?
Oh yeah.
Now, turn the sign around and And then the answer is everything except negative one, because x cannot, or one, x cannot be one in that problem. But in the original problem, x can't be anything. It's not gonna work, you know. You guys on target there? All right, I need one more volunteer quickly to come up and do example 5 for us.
Enzo, what'd you say? Did you say when you go up?
Who can do number 5?
Enzo's stepping up.
Did Enzo volunteer?
I heard him volunteer.
All right. Oh, he lost out. We got the big guy up.
Oh, I don't know about that.
Messing around.
No, I have to watch and learn.
All bark, no bite.
Yeah. Yeah.
I don't see you stepping up either. We're good.
I'm not barking.
Checkmate. Checkmate.
I'm no barking.
Stop.
Hack, pay attention.
I don't see you guys on Monday, right?
No.
Okay, that's all right then. So we're gonna have 1, 7, and 1, 8 are both gonna be due on Tuesday. 1, 7, and 1, 8 got plenty of days. Got 4 days to get it done. 1, 7, and 1, 8 due on Tuesday. If you have recess next period, you can probably crank them out. Oh,
I won't. That's actually, I need to not one. I need someone to not one. Other than myself. 'Cause I can't go. I need that.
Terry Jr.
Okay, let's take a look at this and see what we think. First of all, -2 should be a solid dot, right? So he's got a bracket there, are you okay with that? And 1 should be another solid dot. So he's got a bracket there, okay? And 2 should be an open dot, he's got a parenthesis. Now, is the shading correct? What's wrong with it? Gus? So if we pick a number in here, like 0, 0 would make a negative, and a positive and a positive, and a negative. He said that should be positive. I think that is positive, isn't it? Did you try this section out here?
No, I forgot about it.
Okay.
And at the end, I just said
Okay.
it might not matter.
Well, let's see if it does matter. So if I put in a number like -3, I'll be negative. That's going to be positive, and the denominator is going to be negative. Does that matter? It surely does. Since that is a closed dot, how can I express this? I don't need to do 2 pieces here. I can do it all in 1.
Just the
How does that look to everybody? Does that look okay?
Yeah.
Everybody's good with that? All right, now we're gonna solve one. We've got 2 more problems to do. Take a look at example 7. Now you got the picture. Use the graph to solve the inequality. Where is f of x? What's f of x? Y. where is y negative in this picture? Which x's give you negative y's? Negative 3 to negative 1,
2 to 3.
and, or I should say, or from 2 to 3? Now, why are there brackets on the 2's, or well, bracket on the 2 and the negative 1, but there are parentheses on the 3 and the negative 3? And so?
Because the line is going through the negative ones,
So,
or like it's including
the
negative ones.
problem was less than or equal to, right? So that means it can be 0. And at these 2 points, it actually is 0. Why are these not? They're asymptotes, and asymptotes are not ever part of your answer, right? X can't be negative 3, so those are gonna be that good. How about f of x positive? So where is y positive? What are you gonna say? Negative infinity to 3, or negative 3. Where else is it positive? From negative 1 to 2, and this time I'm not going to include those because my symbol is a plain greater than. And then from 3 to infinity. Everybody good with that?
Why isn't the negative 1 and 2 brackets?
Because the symbol is not or equal to. So if those dots are technically open. Now, I want to be greater than or equal to 1. Where am I greater than or equal to 1? Negative infinity to negative 3, or
3 to infinity.
3 to infinity. You okay with that? All right, I need to throw one more problem at you because as awesome as Mr. Passwater is, he really was too nice to you in this exercise. What if we had 2x plus 1 over 3x minus 7 greater than or equal to 4? Now, graphically, I could do this, but what if I have to do it algebraically? What is different about my problem than Mr. Passwater's examples? It's a 4 instead of a 0. And if you are going to be talking positive and negative, you have to have a 0. So, I know what you're tempted to do, and I'm going to try to explain to you why you can't do it. This is how you're going to get your 0. You're going to get your 0 by subtracting 4. And then building a common denominator so that you can create one fraction greater than or equal to 0. So I'm going to move whatever number is over here, I'm moving it to the other side. And then I get a common denominator so I can combine it. So what am I going to have? 2x minus 12x, negative 10x. And then 1 plus 7, 8. Now I would have a dot for the top and a dot for the bottom, and I could do my shading and all that. Now, I know what some of you were thinking back here at the beginning. You were thinking, oh gosh, it'd be a whole lot easier if we just did this, right?
Wouldn't it be, 4 times negative 7?
Oh yeah, so it should be what, 29? Thank you. Thank you, yeah, I understood the
Call it.
forward too.
You know,
Yep, thank you. What's wrong with that? That's what you're tempted to do, why can't you? Tell me about multiplying in an inequality. Are there any special rules about multiplying in an inequality?
If there's a negative,
If there's a negative, you flip the sign, okay, so tell me about that. Do I have any idea if that's positive or negative? Could it be either one? Yeah, so I can't do it, because I don't know whether to leave my sign the same or switch it. Alright, okay, so all that homework, 1-8, 1-7, due on Tuesday. Feel free to turn it in early.